According to the pseudocode that we have written previously for exponential searching algorithm implementation, let's quickly write the C++ implementation of it and let's just validate it on the array of values. Okay, so inside the searching folder, whatever we have created, right? And there, let's just add one more file called exponential searching.cpp. Okay, here let me just minimize the file explorer and let me just import the basic boilerplate. Along with this, let's just also include the vector that we will be using. Okay, now just like any other implementations that we are doing, let's just write the class exponential searching. Okay, here let's just write a public method in which in the end we will return the index at which the value is available, otherwise we will return -1. As a result, the return type of the function is int, and let's name the function as exponential searching. Okay, what it does, it will take the array of values and it also take the value that needs to be searched in the array of values that we have been given. Remember that just like binary searching algorithm, exponential searching algorithm will also only work in the array of values which are sorted in the either in the ascending order or in the descending order. Here in our implementation, we are writing the implementation for the array of values which have been sorted in the ascending order. Okay, so that is something to remember. So as part of the exponential sorting algorithm, first of all, what we will do is, instead of applying the binary search on the entire array of values, first we will try to find the range in which basically the value could be potentially available. That means first of all we need to find the start index and end index in which the value might be available. Once we find such range, then we will apply the binary searching algorithm on top of those values and we will basically try to search the value that user has asked us to search for. Okay, anyway, for that range calculation, that means for finding the start index and end index in which the value could be potentially available, let me just define one variable called range. In the beginning, remember, we always initialize it with 1. Okay, I will explain in 1 minute why we initialize it with 1. Okay, just wait for that. Now what we will do is we will simply be running a loop as long as whatever the range variable that we have defined, as long as it is less than the size of the array. Okay, that means there are still some more elements that could possibly need to be compared so that we can find the range. That is what this searching means. Along with that, whatever the value we have at this range value, if it is obviously less than whatever the value that user has passed, that means whatever the value that user has passed could be away from whatever the range that we are currently at. That's the reason why here, along with this size comparison, what we will do is, if the array of the value at the range is less than the value that user has passed, what we need to do, we just need to move on to the next one. In that case, what we will do is we will simply update the range equal to range into 2. Okay, if you see here, why I have initialized this range with 1 is because if I just initialize it with 0, right, irrespective of how many number of times I am running this loop, the range value will still remain 0, because if the condition is matching, we are multiplying the value by 2. So if 0 is getting multiplied by 2, let's just say even 10 times, the value will still remain same and we will basically end up in a infinite loop. That's the reason why I have always started the loop from index 1. Okay, once we break out of this loop, right, this range variable, whatever we have, this will basically hold the end index of the search range that we need to search. So based on the value we have in this range, what we can do is the start will be equal to range divided by 2. Why we are doing this divided by 2? Because this range is giving us the end index till which the value could be available. And the obviously end index is, remember, here there is a small catch that you need to remember. Range obviously represents the end index, right? But if you observe here, the comparison, I mean the mathematical operation that we are doing on the range variable is multiplying by 2, and the additional check that we have here is range is less than array of size. This range need not to represent the largest index. The largest index in such cases is the last index what we have in the array of values that we have been given, which is nothing but either if it is in the valid range, this range is the end index, otherwise this is the last index for the binary searching. That's the reason why we need to find the minimum of this range and the last index we have in the array. So let's just pass range comma the last index, which is nothing but array dot size minus 1. Okay, now this minimum will come from algorithm header, right? So let me just use the algorithm. Let me just include the algorithm package as well. Now we have calculated the start index and end index, basically the range in which the value whatever that user has requested might be available. Now what we need to do, we need to apply the binary searching algorithm on this start and end indexes. For that, let me just first open the binary searching implementation that we have already done, and let me just copy this function into the exponential searching algorithm that we are writing here. Okay, we have copy pasted the same binary searching logic. If you see here, generally in a normal binary searching algorithm, what we will do, we will take the entire array, and we know we need to start the searching from 0th index till the very last index, right? But here in the case of exponential searching algorithm, we calculated that start and end index, so we need to take them as function arguments. So int start, int end. Okay, and this is something that we can remove. Okay, now from here, let me just call the binary searching algorithm with whatever the array of values that we have got, whatever the value that we need to search, and the start index and the end index that we have calculated. Now this binary searching algorithm, if at all if the value is available, it will return the index, otherwise it will return minus, right? So ultimately our aim of exponential searching algorithm is also to return the index. So we can simply do return this one. Okay, so that's it for this one. Now let me just add the semicolon here, and let me just create the object of exponential searching class so that we can call the exponential searching function. So let me just call the exponential searching function here. First of all, instead of writing everything, let me just copy paste these array of values also. Obviously you can type it, but it's just that it is already available, right? Why typing everything once again? So let me just pass the array of values. Along with that, let's just say the value that I want to search is 3. Okay, here let me just get the index or position, whatever you are comfortable with, you can use that. Okay, and after that, cout, let me just print the index, and after that let's just do the end line. Okay, now let's just run it. Run code. Okay, we are getting some exception. Template requires 3 arguments but provided 2. As soon as we executed, we've got an issue, right? I understood the issue. Basically this min function, whatever is coming from this algorithm package, right, it is expecting 3 arguments, but we have only passed 2 of them. That's the reason why we are getting this issue. For that, anyway, let me just remove the algorithm package. Okay, and here whatever the array dot size minus 1, whatever we are passing, right, it is basically going as unsigned long value. So we need to pass it as an integer value for the minimum function, min function. That's the reason why let me just create another variable called last index, and let me just assign it to that variable, and let me just pass that last index to the min function. Okay, so this should basically resolve all the issues. Now if I execute this, the value that we are searching is 3, right? It is available at index 2. So if I execute the program, that's the output that I should be seeing on the console. See, 2 is the value that I have got on the console. Let's just say I want to pass the value 6. So if I search, the value 6 is available at index 5. So that is what we have got. Let's just say I want to search for the value 8, which is available at index 7. So if I run code, I've got 7. And let's just say I want to search for the value -8. And in this case, -8 is not there, right? Ideally, we should be getting -1. Okay. So one more thing that we need to check is, let's just say I want to search for the value 1. So if I execute this, the output that I have got is 0, which is basically the position or the index in the array of values that we have been given. Okay, now why I did check for this very first value is because sometimes you think that we are starting the range value from 1, right? So will our searching algorithm will work for the value at 0th index or not? That is something that we will have it in our mind. So I just wanted to test it out and confirm that as well. Okay, so that is the C++ specific implementation of exponential searching algorithm.